Thank you for the very warm introduction. It was an honor to meet you, and it's an honor to be here. I'll be talking to you all about TypeScript, U, and AI search. And usually, when I give this talk, I ask people if they've heard about any of these things, and people are usually here and there about TypeScript, or here and there about AI search. Hopefully, that's not the case today. So a little bit more about me. I'm Daniel Phiri, as was already introduced. I do developer experience at Weaviate, and you can find me anywhere online as Malgambes. I do write a lot about a lot of things, software included, and I do curate music. I'm a developer artist, Plantad, and a Lord stan. It's been a big week for us Lord fans, but enough about that. Lately, as most people have been, I have been really enjoying building AI-enabled applications on the web. If you follow me on any of my social platforms, you've seen some videos of me building some really interesting projects and products that I share. And aside from that, another thing I've been doing is I've spent the last couple of months working on a TypeScript client for Weaviate, the database that I work for. And so to celebrate this, we're GA, so we went through every stage that software getting released goes through. We had an alpha, we had a beta, and now we're GA. So that's great news. Everything that I'll be talking about is ready to be used, production ready, and I'm excited to get into it. Right. So one thing I also like to ask is, what is your experience with search? I will skip the question and I will show you what most of this experience is like. I have a demo. And so I'll switch to my Arc browser here. And so we'll go to this tab. And here I have a keyword search demo. And so I have a database of tracks, basically. And I want to find a song about respect. I think Aretha Franklin did a really cool song called Respect, and there it is, Respect, Aretha Franklin. I should have a song called Summer. There we go, Calvin Harris, Summer. And so this is a search experience. I don't think this is anything new to anyone. Let's go behind the scenes and see how this actually works. And so this is a Nuxt application that I'm doing, all powered by TypeScript. And so I'll open this, go to my keyword file. And what we're doing essentially here is we have all these songs, Bob Dylan, Like a Rolling Stone, John Lennon, Imagine. And at the bottom here, you can see Summer, Calvin Harris, and Beach Boys, Good Vibrations. And so this is how a lot of people do search, or how search really works is you look at a string that's entered, you look at a string or a list of strings that you have in your data, and you compare the two. And if you have a match, you send something back, right? But that isn't really how human experiences around search work. This is a very mechanical process of looking for something, right? If I said sun, or I added what's going on Ibiza, for example, right? And I just wanted to get songs about summer, songs about the sun, songs about good times. And I put that into my search and I said, good times. I don't necessarily want to look for a song called Good Times, but this is something I want to search for. I get no results because this is exactly what we're doing. This is a very JavaScript-like operation here. We're basically filtering everything that doesn't match the keyword that we enter. And that's how we're doing our match. And this is and can be problematic for many reasons. And I'll get into this. Now, search is in a lot of the things that we do on the internet. And a lot of the operations we run on the internet start with search, whether it's looking for music or movies or looking at things on Wikipedia or doing our shopping. Search is a really big aspect of how we experience not just the internet, but our daily lives. And so I think this is something that's extremely important to get right. However, like you saw in my example, search doesn't really mirror this human-like experience that we have. I don't always look for Summer by Calvin Harris, right? I know I want a song about good times, something melodic. And so that's something more natural that I would look for. And so this is our situation. This is the situation, rather, that we find ourselves in most times. Search works, we get our results, but for a lot of us, it isn't good enough. And so let's get into what's behind this, right? This search approach I like to call traditional. And this, as we've seen, comes with a couple challenges. And an example I could give is I tend to be really curious. I'm the type of person who really likes to look at Wikipedia and I go through so many things. And so a question I would ask is, why do airplanes fly? And so imagine I have this search input and I have a database of articles and I type, why do airplanes fly? With a traditional search approach, this is a valid response that we would get. Why you should fly with expensive airplanes. And when we look at this is a very valid response because we searched why do airplanes fly? And when we do our keyword match, the search term that we entered matches the result that we get. However, you might realize that it doesn't really answer our question, right? And this is how a lot of search works. It's an experience that we, in general, do not really like. And so, to combat this challenge that traditional search gives us, I want to introduce you to something called semantic search. And so, given the same scenario, if we used semantic search, when we have the question of why do airplanes fly, we have our database, a response that we would get from a semantic search like query would be something like this. Dynamics of flight. This is a NASA article and it explains that airplanes move through the air because of their wing shape and this allows them to fly. Now you notice that this response really comes from an understanding of our query, right? It doesn't, there's definitely keyword matches, but it isn't looking for the words in the search term and then looking for what matches that the most and then sends that back to us. It understands the meaning behind this query and then gives us the most relevant result that is in our database. And then this might seem like magic. It is not. It's science. And we'll get into exactly what that is. And the type of science, machine learning. And so if you're looking for sort of like a one-on-one or 101 of how to do or how to get into machine learning, this is also a really great talk to pay attention to. And in a nutshell, looking at the semantic search experience that I just showed and comparing that to the traditional search experience that we saw in the beginning, you would absolutely want to get into this semantic search experience because it has a much more human vibe or human experience to it. And so let's get into how exactly this works. As I alluded to before, this is made possible by machine learning models. And so if you aren't familiar with machine learning models are pieces of software, sort of algorithms that can encapsulate meaning. You put in an input and you get an output that wasn't necessarily defined. You didn't tell this piece of software to do this specific thing. You gave it instructions and you interacted with it, and its output was sort of created by it. And so in this scenario, what we have is we have a bunch of data in so many different forms. And once we pass them through a machine learning model, we get these vector embeddings. Vector embeddings, as you could see here, are an array of numbers that encapsulate the meaning of information. So they store this information in a multi-dimensional space. And you can think of each sort of item in this array as a dimension, and each item encapsulates the meaning of this data item. And this isn't something that we haven't seen before. Being developers, being front-end developers, or any sort of developers, you might be familiar with the RGB coding of colors. And so RGB is an encapsulation of the meaning of a color. And so we define colors by grading them on how much red green, and blue they have specifically. And red, for example, would be 255 slash zero, comma zero, comma zero. And that's that embedding. And so you could think of vector embeddings as the same thing. And so some really smart people, really smart scientists have come up with these machine learning models that can create these abstractions of real world things. And so what that means is we could get a sentence and put this into a machine learning model and create these vector embeddings that other machine learning models can use to understand this information much faster than having to manipulate text or images. Right. If you have any questions, you could leave them in the chat and I'm happy to get through them a bit later. Right. And so now we have this understanding of vector embeddings and this relationship that they have with machine learning models and how vector embeddings create these abstractions of real world information. We go back to example of why do airplanes fly? We get all our data. We have this data set. And so we get our Fly with Expensive Airlines article. We pass that through our machine learning model and we get our vector embeddings. We do the same thing with our NASA article. We put that into our machine learning model and it outputs vector embeddings that represent that specific piece of data. And once we have all these vector embeddings, we then plot them in a vector space. Excuse me. And what a vector space allows us to do is by design, having these different multidimensional objects, we tend to have similar objects placed in this vector space close to each other. And so in this example here, you could see chicken, cat, wolf, dog. These are all animals. These are all related items plotted right next to each other. And on the right here, you could also see the same thing, banana, apple, as well as tech companies all plotted. And just by plotting them and having sort of a similar abstraction, they tend to be close to each other. And also, I think it's worth mentioning that this representation that I show is 3 dimensions, but vector embeddings in the real world can be hundreds to hundreds of thousands of dimensions. And that's why you would need a specialized piece of software to handle and operate these things. Right. So we have this vector space. Once we get our vector embeddings, we then point those vector embeddings somewhere in a vector space. And then this is where our query comes in, back to our question, why do airplanes fly? So in a semantic search scenario, when we type, why do airplanes fly, that goes into our machine learning model and we get our vector embeddings. We then point that vector embedding into our vector space. And like I mentioned, by design, similar items that have sort of their abstraction very close to each other tend to find themselves next to each other in this vector space. And so once we plot our query in our vector space, we look around our query and run calculations to see what items are closest to our query. And so in our case, when we look what's closest to this query, why do airplanes fly? It happens to be the NASA article. And that happens to be the most relevant answer to our question, given the data set that we have. Right. And the beauty of vector embeddings, as I sort of alluded to earlier, was you don't necessarily have to only have text. Because you have this singular abstraction as vector embeddings, you can have so many different types of data sets that you put in, normalize, and then have your vector embeddings. And so we can extend that from you have text of a maxi summer dress with no sleeves, and you get your vector embeddings. You could also do that with an image and get an image of a dress and get your vector embeddings. And what that means is you can now search through images and text as well. And at the end of this, I have a bunch of really cool resources for apps that I've built that do things like that. And so if you stay to the end, I'll share a link to some resources that you could check. You could demo out an application. And I built this multimodal demo in Next.js and Weaviate that lets you search through data. Really cool thing. Just like cool in general. I have a lot of other interesting multimodal apps. This specifically uses a clip model. I have one that uses one of Google's Gemini models. And so there's a lot of really cool things that you could do with this. And all of this is powered by Weaviate. All of this is brought together, rather, by Weaviate. Once you have those vector embeddings, Weaviate is an AI native vector database that treats these vector embeddings as first-class citizens. And so your database is specialized for storing, retrieving, searching, and just running operations on these embeddings. And the demos that I'll be showing you today are built with Weaviate also. We have a JavaScript/TypeScript client that we just got into GA, and we have various deployment options also. And so if you want to run this locally on your own or use a cloud provider, we're open source and let you have the flexibility to do anything that you want with your embeddings. Truly, we believe that they're yours. And so having understood how this semantic search works, the sort of magic behind it, how the science is developed to enable this search application. I want to take us through what I like to call a search workflow. Before we get into actually building a vector search application with TypeScript, I want to show what you need to do to get the most out of something like AI search. In this case, that's vector/semantic search. Right. So anytime we're dealing with data, and even more relevant in our specific case, importing that data is extremely useful and extremely important. And so we have new objects that we have, and these objects are passed into our application. And through a single API call, we pass those objects to our vector database. Once those objects are in our database, we can then interact with our machine learning model to create these embeddings. And so when we get our data, when we get our objects in our database, we store them, really important. We store those objects, and then we pass the objects to our machine learning models. Our machine learning models create vector embeddings, which we then store alongside the corresponding objects. Because really importantly, as you do search through your database, you want those objects to be returned. And so this is what the import process looks like. And then let's look at querying. Why do airplanes fly? How do airplanes fly? This is the query that we're putting into our application. And so once we send that through our application, it sends this query to our vector database. This then sends this term, how do airplanes fly, to our machine learning model. And then we then get back a query vector that we then pass to our database. Our database sort of acts as the vector store that I explained. And so we run a nearest neighbors search and look for the most relevant item in our database, and then send that relevant, or at least that list of relevant objects back to our application. You can run all sorts of things like filter, etc., etc. And then in our case, that's the NASA article. And this is how you get from importing data to querying data. And now we can actually go and build something. So today we'll be using a machine learning model from OpenAI. We have various other machine learning models that we support, like Cohere or Hugging Face. If you have a model deployed on Hugging Face, you can use that through Weaviate. We also support other model providers like Mistral or Llama or OctoML, and a couple of the AWS models as well. Right, so let's actually build this out. I'll open my application. Before I do anything, I will just show you what that looks like at the moment. And so we have this page here, vector. And so what we want to do is we want to have more human-like searches. And so the data set stays the same. It's a bit expanded. We have music data from Rolling Stones that covers different songs from the last century. And so we'll be able to search through that library of songs. And so right now when we search something, let's actually search something, maybe summer. We don't really get anything because I don't think the application is working, which is totally normal. So what we'll do now is we'll open our Next application. So this application is built with Next.js, and I will close this just so it's a bit better. And so what we're doing now is we have this page application. We get the input from our user when we search something, and then what we do is we then pass that search term as a query to an API that we've built. So we have new search, and so I'll open new search here. And inside new search, we import our Weave8 client. We use Zod for schema validation to make sure that our query matches the schema. And we initialize our Weave8 client here. And we use Weave8 Cloud Services. I mentioned we're using OpenAI. And so we pass in a header for the OpenAI API key in our server. And then once we have our validated query from the front end, we can then run operations. And so here I have search term. The first thing I want to do is initialize a collection that we can interact with. And this is where the TypeScript side of things really starts to shine as we actually build something. And so I'll say const my collection, and we'll say client dot collections dot get. And we'll get a collection called Calvin Harris. I named this collection Calvin Harris. And then once we have this, this variable that we use to interact with our collection, we can then run different operations. We want to make a query, we want to make a semantic search query to be specific. And so we'll say const response is equal to, we'll have to await this and say my collection dot query dot text, and we'll pass in our search term as a parameter. And then in here we can pass what is the second object. And so we have args here, and what we can then do is say limit to 5 responses. And so this is really cool. And then what we do is then we'll return response dot objects. And so I just want to show off some of the type safety. The really interesting thing that we could do with our collection here is once we have a collection that we want to interact with, we can then run various operations. We're doing a query here specifically, but I could do an import. And so I could say, I'll just say await, await my collection dot data dot insert, and say I want to insert data, and I would say this is album, and then Germany. I'm in Germany right now, so that's top of mind. And as we're building this, this looks perfect. This looks great. But really, we could make this shine by using the generics that this client supports. And so we could pass in a type here that we imported, and then we have type safety, and we know exactly what the shape of the objects in our database looks like. And so immediately we add that there. We have this saying, you can't assign this only this parameter because there's a couple missing. And when we actually look at track search, we see here that we have title, artist, album, year, rank. And so when we actually add those, the error disappears. And this is sort of the type safety that we have out of the box with this client. And when I hover over this, I can see that my response is of Weave8 return type, and to be specific with track search, which means if I go over objects, it should be able to give me album, artist, rank, title, year. And so I have all this information that I can work with, which if I get rid of track searcher here, all that lovely goodness disappears. I have almost no idea what I'm doing or what I'm working with. And so, like in applications that you build that you want to scale, this is extremely important. Okay, so that's just me showing off some of the TypeScript stuff. To go back to the actual application that we're building, we'll pass response.objects, and once we pass that back, we go to our vector.view file, where we then display our data. And so we have search results here. And so we're changing the value of search results to match this, and then displaying this data in our page. So let's go back to our browser, and when we refresh this and we say summer, let's see what we get back. And so now we don't even have to specify. There's the understanding that the Beach Boys has something to do with summer. And when you look at a lot of these responses, they're very summery songs. We could do the same thing about food, for example. So you see Fast Domino, Little Richard, The Beatles, a spoonful. And so all of these results are relevant to food. And we could make this more human and say, give me songs about colors. I think this is a really interesting one because I won't specifically mention any color. But here we have James Brown. Maybe it's the weird spelling. We have James Brown, Prince, because the album also is something that's really important. It also looks at the album. And so a lot of Prince's albums mention color. I forgot to say songs. Just say songs about color. Right, and we have Pink Floyd appearing, and we could expand this. Let's say songs about Africa, and then we get all these different responses, which I find extremely interesting. So I see that we're not displaying. Yeah, so we have artist by artist, but we aren't really displaying title. And so we could extend the type safety that we showed in the server side to the front end here. And so now when I have my generic here, we could make use of the type safety that TypeScript gives us. And now we can say, I want the title. And now it starts to make more sense, a lot of the queries that we were seeing. So songs about color, see a whiter shade of pale, say loud and black and I'm proud, brown-skinned girl. Songs about food. I don't remember the other queries that I put. So Dominoes, Summer in the City, Sweet Old Child, Guns N' Roses, Tutti Frutti. But basically, you start to see that there's an understanding of the query that I put in, and then as you receive these items, you can see the relevance between the query and the response. I find this extremely interesting. Now, one really interesting thing that people do, let me just check how I'm doing on time, actually. We're almost there. So I will do this really quickly. We can expand this search that we have to interact with large language models. And so what I'll do here is I'll add another parameter that says grouped prompt. And so I have a grouped task, and then I will ask my LLM, what is your favorite song from this list? And so if you've heard of something called RAG, Retrieval Augmented Generation, this is it in practice with what looks like 10 lines of code. You run a search, and so you give your large language models data to work off, and it gives you more relevant data and stops it from hallucinating. And so I'll ask my LLM, what's your favorite song from this? What is your favorite song, basically? And so what I'll do there is just pass response, and then inside my vector, I have a section here where it has results, and we'll say search result dot nope, search result dot generated. So this, because I haven't fixed the types, it should not work. And then I'll say dot objects. I'll just get rid of that so it stops screaming. But let's say songs about color. So my favorite song from this list is Brown Eyed Girl by Van Morrison. And so you have this, if I just asked what's your favorite song, it doesn't know what list I'm asking from in practice. So I just found that as really interesting. And I think a lot of people building AI applications want to implement something like this. And so just in the interest of time, I'll stop. I have so many interesting demos that I would like to show you, but I don't have time. But I hope you have learned something about building better search experiences and integrating AI into your applications, your web applications, your server-side applications, also leveraging the robustness of a tool like TypeScript. And if you're interested in seeing a lot of the demos that I showed, using them, cloning them, working with them, here are some resources that you could check out. And just to extend this, we're also running a JS June. Excuse me. And so this is a webinar series. If you'd like to learn more about building AI applications in your favorite framework, be it React, Vue, and Angular, we have 3 very intimate sessions that we have planned where we just give you hands-on experience and we walk you through how to use these specific frameworks with a tool like Weaviate. And that is enough for me. I do not want to take too much of your time, but hopefully this was useful. And if you've got any feedback, please share it. Hopefully I have some time to get through some questions. But yeah, I think I had a little bit too much fun with the demos. And yeah, thank you so much.
Hey, Daniel, thank you so very much for that talk. I love your slides, by the way. The illustrations on there are beautiful.
Thank you very much.
So we do have time for a couple of questions.
Okay.
Real quickly, how do you see the future of AI search evolving, especially with advancements in machine learning and AI technologies? So, yeah.
That's a great question. I think one big theme that I see from AI search is enabling the local user or the local use case. A lot of how we interact with AI at the moment is in someone else's cloud. And I know so many people are working hard to make sure that a lot of the machine learning models are accessible on our machines, because that's a lot of where we do things. A lot of the times we aren't connected. And so I think a big part of the future is more local, contextual search use cases.
Very interesting. All right. So more local machine learning. You can tell I have almost zero knowledge of AI, besides for chatting with ChatGPT. But yeah, that's great, Daniel. Thank you.
That's the point of the talk. It's to democratize a lot of that. It's a lot of people interact with ChatGPT, and I think a lot of us ask, "Hey, what could I do, or how could I use this in the applications I built?" And this is why I did this talk, to help people get a better idea.
Awesome, love it, dude. All right, so last question we have time for. What are some of the challenges that developers face if they want to implement a search like this?
So I think the challenges are more decisions you have to make. And as you implement something like semantic search, it's really important to figure out what model you want to use, because there's various embedding models that create your vector embeddings. And so sometimes semantic search won't work with a certain model on your specific data set. And so there's an aspect of trying and then failing and trying and then finding a model that works. And sometimes semantic search alone isn't enough. You can expand semantic search with something like hybrid search. And these are some of the challenges that you might face.
Awesome. Well, thank you so very much for both your talk and sticking around and answering a few questions with us, Daniel. Really appreciate your time and expertise, sir.
Anytime. Thanks again for having me.
Absolutely. See you around.
Yeah, take care.